Okay, so just to recap real quick, we've got a parabola. Now that we're recording, the set of points that is equidistant from a point and from a line. That point is called the focus. The line is called the directrix. This is kind of a picture of what we have going on. We've got our parabola. We've got our axis of symmetry with the vertex on it. The focus is also along that line. The directrix is a line directly underneath the parabola, it's behind the vertex. Depending on the directionality of your parabola, it'll be different. So it's a set of all points that are the same distance from the focus and the directrix. So you can see that the vertex is exactly in between the two. And if I make a line from the focus to any other point along the parabola, that point is the same distance down to the directrix. This width here is 4p, and when we write things in p form, we see where that comes into play. This is all of our stuff for p form. This is the standard format for p form for depending on the direction that it opens. And then we have the vertex, focus, directrix, and axis of symmetry, all based off of this stuff. So what we should be able to do now is, given any two pieces of information here, like the vertex and the focus, or the focus and the directrix, or the vertex and the directrix, we should be able to figure out how to put this into p form and write the equation for our parabola. You should also be able to be given any point along the parabola and one of these other pieces of information and be able to put it into, write an equation in p form for this. Okay, so this is all good. We're going to take a break from this for a moment and take a look at something that I find interesting. It's something I found on the internet. It's actually a Desmos thing, I believe. Yeah, a couple of Desmos things. So these are some visual aids in case my drawing wasn't that great. It's a little bit, clouded and confusing, but there's two different things here. First is for the up and down. We've got this picture of, it says the red point is the vertex, the orange point is the focus, the dotted black line is the directrix, and the length of the orange line and the length of the green line are the same, and both are p in distance. So we have that. We've got this point here that you can see along your parabola, any place that you have this. It's the same distance from here to the focus as it is from here down to the directrix. And you can change values like h and k. You can move your vertex around. You can move your vertex up and down. You can change the focal width to make, you can see as p increases, your parabola becomes wider. As p decreases, becomes skinnier. If p is negative, it flips over. So I've posted this in Google Classroom. You can play around with these. They're kind of fun. Let's see. They graphed with vertex form. We're going to graph with p form. And you can kind of scroll through all of the coding here. This is how they set it up, but you don't have to scroll through all of that. Whoa, we zoomed way in there. Okay. Anyways, that's kind of a fun tool to play with. You can also take a look at it sideways, what it looks like. So you can move around your vertex. You can move around. You can change p to flip it left and right. It opens to the right when p is positive. It opens to the left when p is negative, that kind of thing. Yeah, so anyways, just more fun things to play with. Okay, but getting into kind of the nuts and bolts of how we might actually write an equation in p form given other pieces of information. Let's get into some examples here. So you're going to want to keep this off to the side or, in your notes that you can refer back to. Now we're going to talk about writing equations. So the first one we're going to do is given the focus and the vertex. Okay. So for this one, we're going to be told that the focus is -4, -3, and the vertex is 1, -3. So step one, for those of you who like steps for things, we need to find, or our goal anyway, is to find H, K, and P. And a lot of times it helps with figuring out which situation we're dealing with here if you start a little bit of a graph. If I know my focus and my vertex, I'm just going to graph those 2 points really quick. We have -4, -3 for the focus, and we have 1, -3 for the vertex. So if this is my vertex and this is my focus, I know that my parabola is going to look something like this, because the focus needs to be inside the parabola. And so if this is my vertex, it's going to open to the left. So that means we're dealing, first off, we know that we're dealing with the opening left to right version of things, or left or right version of things. So that means we're going to be using all the equations that were written in red here. So anyways, back to finding H, K, and P. Off to the side, we might note that we're opens left, so that we're using y minus k squared equals 4p times x minus h. Just as a little side note. But anyways, for the vertex, we know the vertex is hk. So that tells me then that h is 1 and k is -3. So we've already got that bit of information. So now we need to find p. And I'm going to find p using the focus and the fact that I know what h and k are. I know that the focus is h plus p k. So if I plug in what I have, I know the focus is 1 plus p -3. And I also have a coordinate for my focus. So I'm going to take this coordinate and use it down here. We know that it's equal to -4, -3. So I know that 1 plus p has to equal -4. So I can use that to solve for p. So -1, p is -5. All right, so now we have h, k, and p. We have h, k, p. Now we have to write our equation. And we know from looking at what it might graph to that it's going to open to the left, and we're going to use this equation. Y minus k squared equals 4p times x minus h. So now we're just plugging in our values for h, k, and p. We know that k is -3, we know that p is -5, and we know that h is 1. So y minus -3 gives me y plus 3 squared. 4 times -5 is -20. And then x minus 1. And there's our equation. And if you want to check yourself and graph it, you can make sure by graphing that the vertex is indeed at 1, -3, that the vertex is inside the parabola, and that it opens to the left. any other questions at the moment here? Anything we want to go back to from this example? Any numbers that don't quite make sense or we're not sure where they came from? Okay. So that's one kind of thing we want to be able to do. Let's try another. Let's do... Hold on, let me find one that's not going to be, or it's going to give decent answers here. Okay. Oops, there we go. We're gonna do the focus is 2, 1, opens right, and contains 8, -7. Okay. So first we have the focus, but we also have that it opens right, and that's going to be important because just telling you a point that it contains doesn't always tell you enough about it. So if it tells you that it contains a certain point, we do need to also know which direction the thing is going to open. Okay. So since it opens right, that tells us we're going to use that red set of equations that we had. Y minus k squared equals 4p times x minus h. We also know that since the focus is 2, 1, our focus equation for that opening left to right set of equations is h plus pk. And then containing this point, that tells me we have an x and a y value that fit into this equation. Okay. So what I can do really quick here is I know what k is. I can plug k into the equation. I can plug an x and y value into the equation, but I can't really plug in an h or a p here because I have that 2 is equal to h plus p. So what I need to do really quick is solve for h. So if I subtract p on both sides, we get 2 minus p equals h. So now I can plug in this for h. I can plug in k is 1. I can plug in x equals 8 and y equals -7. That's all the stuff that I have. I'm going to plug it into this equation here. So we have y minus k squared equals 4p times x minus h. We know that y is -7. We know that k is 1. We know that x is 8 and that h is 2 minus p. So when I plug it in, we get -7 minus 1 squared equals 4p times 8 minus 2 minus p. The only thing you really need to be careful of here is when you have minus 2 minus p, we have to make sure we distribute the negative. So this becomes 8 minus 2 plus p. And this becomes negative 8 squared, which is 64. 8 minus 2 is 6. So we have 4p times 6 plus p. Okay. Then we can distribute. We get 24p and then plus 4p squared. And now we have a quadratic that we can solve for p. So this version of the problem is a little bit lengthier than just the focus and vertex version of the problem. So we get, if I set it equal to 0, we get 0 equals 4p squared plus 24p minus 64. And then here I can start by factoring out the GCF of 4. And then to factor it, we're looking for things that multiply to negative 16 and add to 6. So that would be 8 and negative 2. So we get p plus 8, p minus 2. So p is either equal to negative 8 or positive 2. Okay. So now we're at a point where we have to decide which p-value is going to work out. And we know that this thing opens right. So if it opens right, right gives us a positive p-value. If it opens to the left, it would be the negative p-value. That's how we decide. And now we have a value for p, which means that we can figure out what h is, and then we can plug everything into the equation. Okay. So we knew from back up at the top that 2 was equal to h plus p. So 2 is equal to h plus 2, which tells me that 0 is equal to h. So now we have h, we have p, and we have k, because we knew back up at the top that k was 1. Okay. So now we have h, p, and k, and we are good to go with writing our equation. So this was kind of the first long step of finding p. Now we just have to fill in the blanks. We have y minus k squared equals 4p times x minus h. And we know that k is 1, that p is 2, and that h is 0. So y minus 1 squared equals 4 times 2 is 8 times x minus 0. So just times x. And there is our equation. So that's another version of how these problems can go. So looking at that one, I know that was a little bit more complicated of an example. Any numbers we're not sure where they came from. Any steps we're not sure how they happen or why they happen. Okay. Then, let's see. We'll do one where we're given the directrix as well. And then we'll do one more kind of problem that's a little bit easier than this kind. All right, so this time we are going to be given the focus, which is going to be 3, -1, and the directrix, which is y equals -7. Okay, so with this, what I would do first is kind of get a picture of what we're dealing with here. Where are the focus and directrix located with respect to each other? So y equals -7 is down here, and that's where our directrix is going to be. So if your directrix is a horizontal line, you know that your parabola is going to open up or down. But also the focus is 3, -1, so over 3 down 1 would be somewhere around here. So we know that our parabola is going to be somewhere in between, about halfway in between, actually, those two things. So we know, like, that's going to be a picture of what our parabola looks like. So we know it's opening up and down just based off of the focus and the directrix. So that means that we're going to be using x minus h squared equals 4p times y minus k, our other set of equations. We also know that the focus is hk plus p, and we know that the directrix is y equals k minus p. So if I'm looking for hk and p, like we always are, we're trying to find hk and p, I know right off the bat that h is 3. Then I know that -1 is equal to k plus p, and I know that -7 is equal to k minus p. Well, look at that. We have 2 equations and 2 unknowns. So you can use elimination or substitution to solve these. I kind of like elimination here. It's set up very well for that, because if I add these 2 equations together, p and -p cancel each other out. We're left with 2k and -8. So dividing by 2 on both sides, we get that k is -4. So that we can add to our list of things that we now know. And then I can take this and plug it into either of these. We can go -1 equals k plus p and plug in -4. Adding 4 to both sides, we get that p is 3. And now we can write our equation. So x minus h squared equals 4p times y minus k. Plug in a 3 here, a 3 here, and a -4 there. So x minus 3 squared equals 4 times 3 is 12, times y minus -4, which is plus 4. Okay, so a lot of this is just taking what you're given and writing the equations for the things like hk and p, or anything that involves hk and p, and then figuring out, okay, how can I solve for hk and p? What do I already have? What do I need to do to solve for them? Okay, any questions with that one? Any numbers we're not sure where they came from? Steps that don't quite make sense? Okay. Then the last kind of problem that we are going to look at together today is where you're given the equation and you get to find the vertex, the focus, the directrix, the axis of symmetry, all that kind of stuff, pulling it from the equation. In P form, though, this time. So, example 4. We have x, let's see, we'll go x minus 7 squared equals 16 times y plus 8. And we are going to find the vertex, focus, directrix, and axis of symmetry. Alrighty. So looking at this one, we know we're dealing with one that opens up and down because it's that x minus h squared kind of format here. So step 1, find h, k, and p. Well, we know we're working with x minus h squared equals 4p times y minus k. So that tells me that h is 7 here. K is negative 8, since it's y minus k. And then p, well, we know that 4p is 16, so then p must be 4. So we have h, k, and p. Step 2, the vertex is just hk here. So that gives us the vertex of 7, negative 8. Then the focus, we know, is hk plus p. So that would be 7 and then negative 8 plus 4, since p is 4, which is 7, negative 4. Then we want the directrix, which is y equals k minus p. So negative 8 minus 4. So y equals negative 12. And then lastly, axis of symmetry, which is x equals h. So in this case, x equals 7. All right. So with this sort of problem, once you find h, k, and p, it's just taking then all of your equations for vertex, focus, directrix, axis of symmetry, and plugging those things in. Okay. I'm going to give you guys a couple to try, and then we'll see where we're at that point. So make sure you've got these in your notes, because you're going to want to use them. And let's get to those you try problems. All right, so the first one, we have y minus 4 squared equals, we'll go 8 times x plus 9. And I would like you to find vertex, focus, directrix. Oh, sorry about that. Thank you. And axis of symmetry. Second one, we'll do, given that the focus is, let's see, we'll go forward 2. The Directrix is x equals -4. Write an equation for the parabola. Okay, so take a moment, try those two. When you've gotten to the point where you think you have the answers, or you get to the point where you are stuck, type done in the chat. And we'll go from there. You figured out that H is -9, P is 2, and K is 4 for the first one. You're on the right track. On the second one, if you're getting started there, this should be opening to the right. So we're using that y minus k squared equals 4p times x minus h. So if you started with that, you're on the right track. Remember to let me know in the chat when you think you've got it. Focus is what I put, or is I just put that for instead of writing out the word vertex, focus, directrix, and axis of symmetry. Oh, okay, no worries. If you got negative 9, 4 for the vertex on the first one, you're right, it's just HK. And then negative 7, 4 for the focus because it's H plus P, K, and P is 2. And then we have H minus P, so that'd be negative 11. And then Y equals K is the axis of symmetry, so Y equals 4. So there's the first one. Give you another minute on the second one. On the second one, if you set up your two equations, you should have 4 equals H plus P and negative 4 equals H minus P. So setting those both up and then adding the equations together would be a good next step. So if you're checking your work here, if you solved for h and got 0, and then solved for p and got 4, and then found that k was 2 from the focus, then you're ready to go with setting up your equation. How did you get -7? Okay, so in the first one, the focus is h plus p k. And so -9 plus 2 is -7. Oh, yeah, no worries. Okay, so then here we get y minus 2 squared, since it's y minus k. 4p would be 4 times 4, which is 16, times x minus 0, so just x. So that would be our equation for number 2. Okay. So looking at either of these two, are there any numbers we're not sure where they came from? Any steps we're not sure how they happen or what's going on? Okay. So on a scale of 1 to 5, 1 being I'm totally lost, 2 being I probably just need some more examples, 3 being I think I just want to try some of these on my own, 4 and 5 being this is pretty darn easy for me, what are we feeling right now? Okay. Awesome. Thank you for voting, those of you who did. Looks like most of us have. Okay. So today's homework is going to be fairly short. It's 8 problems, and they're all pretty much like these. We'll get more of stuff that's similar tomorrow, but it is a worksheet. And I want to take a look at it with you both, or look at both pages with you real quick, because there's a bunch of stuff on there that's like extra examples and whatnot. So there really are only 4 problems per page. The first page, there's the 4 problems down here under where it says exercises. It has some example up here and like a paragraph talking about it up there. But this is the same kind of problem as the try number 1, where you're identifying the vertex, the focus, the axis of symmetry, and the directrix, and then it provides space for you to graph it. If you want to graph it using vertex, focus, directrix, axis of symmetry, and all that, great. If you want to look at it on Desmos for some extra help graphing it, feel free. And then the second page, we've also got 4 problems that are a lot more like example, or the try number 2, where we're given like focus and vertex, or focus and a point, or focus and directrix, or vertex and directrix, that kind of thing. So there's 4 of those and an example up here. And that is your assignment for today. Any questions, comments, concerns before we get out of here? Right. Then you guys are free to go and enjoy the rest of your day, and I will see you tomorrow.